So, my name is Agita, and today I will talk a bit about DevOps best practices and how they relate to the combination of two concepts, DataOps and Data Mesh. This talk is very beginner-friendly. I will provide an overview of these paradigms and explore how realistic it is to combine them. This talk is made mostly for DevOps engineers curious about data or Ops curious data engineers, and for everyone who is considering to implement data mesh in their workplace. Shortly about me, this talk is a result of my bit of a roller coaster of a career. At the moment, I'm working as a community manager at VMware. I manage the community for Versatile Data Kit, which in a nutshell is a DataOps framework. But prior to that, I have some experience. I had some experience with community management, and before that, for approximately 5 years, I worked as a DevOps engineer. So basically, I came from DevOps to community management to data engineering now. Maybe I'm not kind of a regular IT person because I really love working with people. I'm extremely excited when I can automate manual work and bring efficiency to teams and brainstorm on how they can be more efficient. And the community is my passion, so I kind of managed to combine my skills, knowledge, and my passion. At the same time, talking about the topic of DataOps Mesh, I believe that there are some challenges implementing it, and I'm going to address them also over this talk. So let's start. Even if before I introduce the agenda, I wanted to start with why. Basically, I'm a huge Reddit fan, and I love it for the jokes, of course, but also for the truth that sometimes data engineers reveal by asking questions and sharing their frustrations. I learned a lot about the data engineering problems from Reddit. One of the reasons for this talk is described in this post by Redditor. Basically, boss wants a data mesh, says a lot. And in this post, the person explains that their boss was at a conference and now thinks that data mesh is extremely cool and we need to now implement it. And besides that, clearly, it seems that the boss has no knowledge of data meshes and how to actually implement it. And I wish to address this issue. And another reason is that sometimes data mesh, which is kind of very hot at the moment, is implemented without following the best practices, and then it fails. And here's another person from Reddit feeling the frustrations of implementing data mesh on top of non-existent best practices and literally calling it the Wild West. If you just read a bit here, at my organization, we use any cloud, any storage, any layout, any orchestration, and so on. So the best practices are not followed, and it creates just chaos. So the best practices are crucial for success for data project. And now the agenda. So today I will cover DevOps, DataOps, and Data Mesh. I will cover the basics and the best practices. And then I will explain what is DataOps Mesh in my opinion, because I kind of came up with this, and how it can work in real life. And here I will ponder on what can go wrong, my personal questions and solutions, and how to solve them as well. And then I will show you the DataOps lifecycle as I see it, and bring an example of how I could actually implement my data mesh and DataOps with my personal example and experience. So let's start with the DataOps. I'm going to cover DevOps. Yeah, start with DevOps. DevOps best practices from a purely personal perspective and two projects that I worked on. I was part of the first project for 3 months and the second for 4 years. So for me, DevOps mostly represents two concepts, but of course all of them are relevant, and I will start with automation. So I joined the first project as the only DevOps person in the team. I was assigned to join a team of 5, maybe 6 developers and our lead, and we were sitting all in the same room. And they needed me to perform some repetitive tasks on a daily basis. So basically, on the first day when I joined the project, I received instructions written across 7, maybe to 10 A4 printed pages. And this was the work that I was supposed to perform on daily basis every day. manually. And the task basically was to perform a migration to a newer version of Spring Framework. I was testing in several environments, packaging and deploying the application. And at first, actually, without any previous experience with Java or Spring, I struggled to decrypt the instructions and implement them at least once. But I was required to deliver them much faster than I managed in the beginning. And I had to take one night of overtime to complete them, to get frustrated enough and start actually automating the process. Mostly it was replacing some lines in files, copying, renaming, running some tests. So it was not really complicated to figure out how to automate them. At first, I wrote some regex and single bash scripts to get the kind of these tiny repetitive tasks off of my hands. And but eventually, like one by one, I automated each step of the process that was described on this paper. And actually now, kind of the learning is that if the instructions can be written on the paper, there is nothing unique about them, and they can surely, definitely be automated. And eventually, in 3 months, I automated the whole process that was described there in the paper until I had absolutely nothing else to do in the project, and I got my first promotion. And what I really enjoyed about this project, actually, and DevOps in general, is the idea that DevOps person joins a team, like automates everything that is possible, and then they go to the next project. But my second project was not exactly the same case. But DevOps, firstly, for me, is about automation. Other important points are that DevOps promise is to fail as soon as possible and deploy as quickly as we can. This is why everything becomes faster, better, and cheaper. DevOps lifecycle is a combination of phases of continuous software development, integration, testing, deployment, and monitoring. And later in this talk, I will translate DevOps lifecycle into DataOps lifecycle. As a result of the DevOps, terms like jobs, pipelines, orchestration have appeared and are required now in each, I think, modern tech IT project. And the final DevOps best practice I wish to emphasize is collaboration. So the second project, as I said, I worked there for 4 years, and I think it served as a great learning opportunity for collaboration. From the day one, I was required to travel to Germany every week for this project to work in the same room with my team. The project was quite big. I think we were supporting a DevOps platform for maybe more than 3,000 people who were developing applications. And starting with onboarding, covering the full DevOps lifecycle, infrastructure, CI/CD, testing, deployment, etc. We were supporting all of this. And actually, it removed many dependencies. This is another thing that boosted the effectiveness, because there are a lot of people in the same building and actually a bunch of us in the same room, so we worked really closely together. If anyone needed anything, I was there, and if something was broken, we fixed it on the spot together. Actually, no silos means that the DevOps person with DevOps or DevOps skills is directly in the dev team, which wasn't really my specific role in this project.
Next steps or decisions needed, or we need to make that final.
I'm sorry, I hear someone talking. Maybe we can check if we can use it. So, nevertheless, the result was pretty impactful. In a team of this size, it was crucial for everyone to know each other to collaborate efficiently. And yeah, I think it worked really well. But of course, now the times have a bit changed, and everyone is working remotely. And I was thinking how actually this works. This collaboration can work or be created in a remote setting. At the moment, I'm also working remotely, and I meet actually my team very rarely. I believe that in a remote setting, most impact is created by the collaboration tools and the culture. If a team can talk as they would if they would be in the same room, it's possible to break the barrier of distance. And it's all about team building and communication. Still, I think that the problem in the large companies with the remote setting is that it's very difficult to get to know people beyond the direct team which I'm working with. Like, let's say I'm having stand-ups, but I don't know other teams. So it's important maybe to have some common meetings that are relevant to all the participants in order to promote this collaboration. And eventually, as a result of DevOps, and the benefits that it brings, the best practices were translated to the data world. And in 2014, the term DataOps was coined. Basically, in a nutshell, DataOps is a data engineering equivalent for DevOps best practices. And the idea is to speed up the data deployment while improving the quality of the data. The DevOps principles are followed in the DataOps lifecycle, allowing to obtain accurate data and deploy validated data quickly from the development to production environments. As in DevOps, the automation of the data pipelines and infrastructure setup is supported by many DataOps tools and frameworks. And DataOps is a practice for DevOps, data analysts, data scientists, data engineers, developers, and IT operations collaborating in the entire journey. If previously one team might be dependent on the other team, another, let's say, data team, because of the sequence of the data journey, with DataOps, some dependencies are solved. Besides that, I truly believe that DataOps engineers should be enabled to set up the infrastructure and orchestrate the entire data journey. So in the perfect case scenario, data pipelines and infrastructure are built and maintained by the same people, which is not always the case, because at the moment still data teams might be separated from infrastructure teams, and data engineers might collaborate, let's say, with the DataOps team that builds and maintains the infrastructure and gives access to the data. I think that this shouldn't be the case, and the DataOps person should have the ownership over the infrastructure and full control over the pipelines and orchestration. And in my opinion as well, DataOps is focused on tools and automation, which is kind of decreasing the dependencies, but not entirely eliminating them. Because a DataOps team now is a separate, which means that domain owners don't have a direct connection with the DataOps person, which is where actually Data Mesh comes in. Data Mesh was invented by Zhamak Dehghani in 2019. She was a ThoughtWorks consultant and the original architect of the term. Data Mesh is a type of data platform architecture that leverages domain-oriented self-serve design to embrace the ubiquity of data in enterprises. The domain is a business area, meaning each business owns its data. Data Mesh fosters data ownership among the domain data owners who are held accountable for delivering their data as products. So now, kind of data as a product is also a very mainstream term. Each domain is responsible for managing its data pipelines, and once data has been served and transformed by the given domain and the domain team, then they can leverage the data for their analytics and operational needs. As Zhamak argues, the data architectures can be most easily scaled by being broken down to smaller domain-oriented components. In short, data mesh means that the data owners or domain owners, people who are directly involved with the particular data, are also building and maintaining their pipelines. Users become owners, so the data becomes product and it's self-service. Which in very simple terms means that each domain team has a data engineer or a data practitioner in their team. And this is a great way to solve the dependency on a separate data team. But this alone does not actually eliminate all the dependencies. Because if the orchestration, testing, and CI/CD are set up and managed by another team, then the main team will be dependent on the infrastructure engineers, possibly DevOps, to support the infrastructure and orchestration of their pipelines. And this is how I got inspired to think about the combination of DataOps and Data Mesh, which I strongly believe enables true collaboration and powers up the data engineering process by completely eliminating the dependency. So, If a DataOps engineer owns the data pipelines and is enabled to have ownership over the infrastructure and orchestration of the data cycle, and the data mesh means that the domain owners own the data as well as pipelines, and in this case, infrastructure too. The result can bring speed to the data-driven projects to be as fast as possible with no dependencies. And actually, this is already happening in DevOps world because DevOps engineers or, let's say, full-stack developers can set up the infrastructure, build pipelines, and be in the same room with the developers, or actually be the developers for maximum collaboration. So it sounds kind of perfect, but what can go wrong? Well, I believe that two things can go wrong, or maybe prevent DataOps Mesh from happening. And first, in my opinion, is trust. Trust is really important because domain teams now would have full ownership over the data and infrastructure, when it's possibly more reliable to have infrastructure set up separately from the domain and simply given access to the data. Some companies might not have enough trust to allow the domain owners to own the infrastructure because of the risks that come with the full power of the data, like accidental deletion and so on. This can actually be solved by implementing structure and setting requirements, creating functionalities to prevent this from happening. For example, preventing deletion from the production. And yeah, the second question for me was, do we have the skills? Actually, the skills required to execute DataOps combined with data mesh are, so first, the person is in the team in each domain should have the knowledge about the domain. Then it's necessary to have data engineering skills like, let's say, Python or SQL or whatever is used to build the data pipelines, to build and manage the data pipelines. And the third skill is, in this case, then setting up the infrastructure, automation, and basically DevOps skills. And when I was creating these slides, my question actually was whether it's easy or even possible to find someone with these skills and knowledge for each domain or train them in missing skills. And if it is, if people are even actually willing to learn. But as I was presenting this idea to my team, it became obvious that the skills issue is actually solved by the tools and frameworks similar to one that we're building, that is automating the data engineering and operations process. So solutions, I think, are one of the many frameworks at the moment that can automate parts of the data lifecycle. Still, maybe the strongest feature, particularly of the Versatile Data Kit, is the framework that I'm working with or on, is the fact that it automates the whole DataOps lifecycle. So the best practices are integrated into the framework. The automation of the infrastructure and setup and orchestration are integrated too. And the third part of it is that the creation of pipelines is available to a person with some understanding of technology or previous tech experience, because basic Python or SQL skills are required to build, run, and manage the data pipelines. So it is possible to create a simple pipeline and set up infrastructure just by following the instructions provided by documentation, which is normally the case in each I think also DevOps project, that when we start, we just follow documentation and install and set up the infrastructure. So this could be one of the many solutions to implement DataOps and data mesh in real life. And the VDK covers the full DataOps lifecycle, and here is how. So now I will go through the DataOps lifecycle as I see it, and I will give a little insight to which parts are automated by Versatile Data Kit, and give a real-life example of, to kind of give a real-life example of automation of the lifecycle. So whoever is familiar with actually DevOps lifecycle will see that it's very similar. This lifecycle is still highly debated in the data world. Actually, I've done some research, and based on my research, I made the version that appeals to me the most. I got really lucky with the laptop with the touch screen, so I decided to try out my digital drawing skills, and For the sake of my own fun and pleasure, I actually made this drawing of the lifecycle myself. So I'll go through it step by step, and let's start with the plan. Plan is the first step of the lifecycle and is the most crucial step because we all know that failing to plan is planning to fail. The focus here is on the business value, users' requirements, and the tools that are going to be used are selected in this step. For implementing data mesh, the tools and the automation process must be predefined to avoid the Wild West, so mentioned in the first slides in the Reddit posts. The procedures must be set at the organizational level, otherwise the people will implement their pipelines without structure, which will likely fail. So the second step is the code. Coding is in the data world means that writing the code for a pipeline to ingest, transform, and the data and test it locally. Versatile Data Kit automates this part by introducing SDK. The code can be written in Python or SQL interchangeably and is used to create data jobs with steps that run in a specific sequence. Later on, I will just show a little example of a data job and how it looks like. Templates can be reused to follow the best practices. Also, a database is selected and configured. This is the extract and transform step of the lifecycle. So data jobs are executed locally to test the code and ensure that the data is ingested and transformed properly. Actually, many tools are automating this step. It might be using other languages or even taking the code out of the process and providing some interface where people can just do this part by clicking buttons in UI. So it actually can also be not really coding. So the next step is orchestrate. This is a crucial ops or operations part of the cycle. This step is independent actually and can be done in parallel by ops team while the data team is creating the code. The infrastructure is built here for the data to go through environments like staging to be tested and further promoted to production and used for analysis. This step is crucial to have before test, but as I said, it can be also done, kind of simultaneously with the code step. Typically, code is pushed to Git and the data is ingested into staging before being deployed to production. At this point, scheduling and orchestration of the pipeline is configured using the config files in case of Versatile Data Kit. Orchestration tools can schedule jobs, manage workflows, and coordinate task dependencies. VDK has implemented a control service component that handles the infrastructure setup and scheduling to provide automation of this step. So the next is test. Once a data job runs on staging, the data can be tested. Now alerts for any user or system errors can be tracked. End-to-end testing ensures that no existing functionality is impacted. And data quality testing determines whether processed data meets expectations by testing uniqueness, constraints, allowed values, and business rules. Checking for duplicates, null values, or incorrect values in the data, for example, or things that haven't been considered in the workload, such as what would happen if, and attempting to capture those kind of scenarios. Any bugs and discrepancies are fixed in this stage. So the next is deploy. After validating the data and resolving the issues, it can be deployed to production. Deployments can be fully automated or manual, but no more than like pushing a button or executing a job. With Versatile Data Kit, it's just a simple VDK deploy command that does this part. And we go to execute. The pipeline now is scheduled and running automatically based on the configuration. An automated data lifecycle process is in place, which schedules ingestion, transformation, testing, and the next step is monitoring. But yeah, the reports can be already generated. So monitoring, automated monitoring needs to be in place. With VDK, we have built an operations UI covering this lifecycle step. It's possible to monitor the failing pipelines and distinguish error types and causes between the system or user error. The percentage of successful jobs and the log output is visible as well. Basically, there is everything I can imagine for proper monitoring and debugging of a data pipeline. And the final step is feedback. Before we repeat the cycle, the feedback and additional requirements can be collected to continuously improve the pipeline. Maybe some data is missing, maybe some data is required to add. When the new requirements emerge, we can proceed to the next iteration of the planning phase, and then the cycle repeats itself. Okay, and now I'm going to explain how to implement DataOps and Data Mesh. Basically, on my personal example, when I joined my current team as a community manager, I needed to create a report on my own KPIs. And without any previous experience in data engineering, I was assigned to build my own data pipeline. I was assigned a functional team in the VDK tool, and then I started with the ingestion of my data from GitHub repository metrics to the data lake. I went through the full data lifecycle by myself using VDK in several days. So I did the ingestion, local testing, loading, pushed my code to Git, verified my data in staging, and then when it was seemingly correct, I promoted it to production environment. This whole process I did by myself without much previous experience with actually data engineering. And then I actually created my report. So I knew the requirements for my report, and I believe I was the best person to create it. And just to give you an understanding of how my report eventually looks like, I'm going to quickly show it. So basically, this is my GitHub dashboard. I'm collecting metrics such as like stars and star history, like when a person is starting the repository, how many clones we have, how many views we have per week, clones over time, per day, and unique viewers per day. I also created this say a ratio between unique viewers and the stars that we're getting per day, and basically also I'm tracking some performance, like for example, how many people are coming from the blog posts that we are publishing, and so on. And this is my first basically report in this project. So I'm actually the community manager, and I'm the only community manager in my team. I'm working with developers of versatile data kit, but I imagine that in case of Data Mesh, this could be me in some, like, let's say, marketing or sales department. And it could be that my team is all marketing and sales people who need to track like these impressions, conversions, traffic, and have the reports on that. And with the support of, let's say, one technical person, it can be done within the same team. So the division into teams actually allows me to access the data that is relevant to me, because it's crucial, because the access to the data needs to be sometimes really restricted, but not the code. Actually, the code can be reused by the other teams. And I also have open sourced one of the data jobs to create this report, and I'm going to quickly show you how it looks like. So this is my example job, and basically it creates this. This is the code to create this star history. So basically, how many people are starting the repository like each day. I'm just dropping the table at first, then I'm creating it. And then I run the kind of a bit of a code here to get the stats from the GitHub. And then actually the interesting part, maybe the ingestion and actually loading into the data lake is here. In this case, it's just a local job, but basically what it does is ingesting the data from like the start time and the count of stars into a destination table, which is going to be created locally also when we run this code, when we run this job. It's automatically created, and also the columns in the table are automatically created there as well. Then I have like one file just for the Streamlit dashboard, because in this case I made it as an example for people to try it out. It's going to create a dashboard like this. And then I also have my config files. Here I assign a theme. And as I said, the theme is important because it can set the access, let's say, to my data. I can also schedule my job. Here is like the scheduling. It's very simple, like cron style. And also I can set the database that I'm going to be using for my job also here. And then the last file actually here is just requirements that are necessary in order to run my job. And the requirements I can install by just like running very simple command. So going back to so basically this is how they look like. Final thing is that the jobs are like named in the sequence, and this is the sequence that they're going to actually be executed in. So basically, when I have this job locally, I push it to Git. Like in VMware, we use GitLab internally, and all the teams can see my code. Basically, when I push it to GitLab, when I push it to GitLab, also it automatically gets executed. So besides this, if I need to reuse the same code multiple times, I can write and share templates. And if the code seems relevant for other teams, they can reuse it. So we don't have to reinvent the wheel each time. After successfully publishing my data, I created the report. And then I was also writing some SQL queries that I made, and I also pushed them to Git so they can be reused as well by other teams if they are, let's say, trying to build the same dashboard or something similar to what I did. Basically, in this way, we still keep the communication and collaboration between teams. Everyone has access to reuse my jobs, configurations, and queries. And the code is reused by each of the teams, and the best practices are followed by. So these practices are set by the tool and framework. And this is one way of implementing DataOps Mesh, but the basic idea is to ensure that full data lifecycle can be implemented by each of the teams in order to eliminate the dependencies and enable the teams to fully own their data. And by the way, all the templates we create, or also in VMware internally, we are publishing also to the public repository, and so they're open source and shared with the rest of the world. And now I wish to just dedicate a bit of a moment to speak about the open source community that I'm building. As a community manager, I'm fostering the growth of the community around the Versatile Data Kit framework. And I'm gathering people to inform them about the latest news about the framework that we're creating. Each month, I'm organizing a community meeting that anyone can join. You can find the event on LinkedIn page, Versatile Data Kit page. And in case if you wish to support me and my team in succeeding what we do, you can simply scan this code or Google and find the repository on GitHub, and simply add a star on the top right-hand side. This is a really small but very, very significant contribution that you can do now. And if you find this talk and the framework that I'm working on useful, I personally will deeply appreciate if you support me and my team in this way, because the project then is able to receive the attention that it deserves and also get used by other people. So other ways to contribute is following us on YouTube, LinkedIn, Twitter, and sharing our content, or using the tool and providing us with feedback. And feedback actually is one of the most important ways to contribute, as we are trying to be user-centered in the project and developed it based on the feedback and the needs of the community.